Okay, looking at some just kind of mixed up topics here. um, the big one's going to be talking about the difference between diamond, graphite, and um, graphene, and the different types of carbon, basically. So we're going to start right here with these terms: macromolecular. So macro means big, so big molecule. Giant means big, and network covalent. So these all mean the same thing. So what happens is that you have things um, like carbon, which are nonmetals and are not particularly hard substances. So, for example, I mean, you have graphite if you're using a pencil to take your notes, and so that's graphite, not a particularly hard substance, but in certain situations, you can take something like carbon, which is not a metal, and create something that's really, really hard, has extremely high melting points, such as a diamond. And so when you have these things where you have these very complicated combinations of nonmetals, they are either called macromolecular, giant, or I usually use network covalent solids. These are all where you take a nonmetal and you make a really, really, really hard substance that has a really high melting point. So quartz is another example. So IB does focus on carbon, and they focus on the concept of an allotrope. So an allotrope is just when you have an element and it can have different forms um, depending on how it is bonded. So um, allotropes are different. These are different forms of the same element. So carbon is what they use. That's the one that'll be on the test. That's the one that'll be on the IB test. And so carbon can be diamond, graphite, or graphene. And so we'll kind of look at multiple things. So let's first look at the diamond. So the thing about the diamond is that every carbon is connected to other carbons, and then those carbons are connected to other carbons, and so you have a network. So this carbon here is connected to 1, 2, 3, 4 carbons, and then those carbons are also connected to 1, 2, 3, 4 carbons, and it just continues this process of being interconnected. And so I've got this model over here that I found on the internet, and it kind of shows you this idea. And so actually that's the graphite one. So let me go back and let's show you the diamond one. Okay, so here's diamond. This is a 3D model. And if you look, you can see that every one of these carbons is connected to all of these other carbons. And so what that does is it creates this very, very difficult structure to break these bonds. So carbon, if it gets that fourth bond, it creates this very, very strong structure, which is the diamond. And so if you have a carbon and every carbon in the diamond is connected to 4 other carbons like that, well, we can predict the hybridization. So it'd be 1, 2, 3, 4 bonds. So that becomes sp3 hybrid. So if you look at B, it says each carbon is bonded to 4 other carbon atoms in a crystalline structure. And you want to know this for the test. This is an sp3 hybridization, meaning that it's got more connections. More connections means more difficult to to scratch, break, etc. And so it's just really, really difficult to disrupt this, which is why diamond is your hardest substance that we have on the planet. So you use diamond to on drill bits. So like if you're going to cut tile, cut concrete, cut granite, diamond is extremely hard. If you want to cut another diamond, you use another diamond. And so being the hardest substance known, having that hybridization of sp3, that's really good test information, because there will be some sort of test question looking at the differences in the types of carbon. And so right here on C, it has a very high melting point, and it does not conduct electricity, and it does not dissolve. So it is insoluble, it does not dissolve, it does not conduct electricity, but it has extremely high melting points, and it is a very hard substance. So those are all bits of information you want to know about the diamond. Okay, so let's go back to my model, and if I go back to this one, which is the one I started off first, this is graphite. So here's the difference. See, the graphite, if you look at these, all of these are connected to only 3 other carbons. So those are sets of 3. And they stack in layers because they don't have the connection to hold each layer together. That's how your pencil lead works. Your graphite and your pencil is you're just rubbing off a layer of carbon into the fibers of the paper. And the whole difference is 3 attachments instead of 4. So you can really kind of see that. It's a great model. And then you can kind of see those layers. So let's go back over here to the notes. So graphite, it's an allotrope of carbon, which is just another form of the same element. So in this, the difference is each of these carbons is going to be bonded, and not to 2, not to 4, but to 3 other carbon atoms. And that's going to give you an sp2 hybridization. So there's another difference. It's got a different hybridization. And so because of that different hybridization, it's just not quite as strong. If we draw out 3 of them, we can see that hybridization. If I do 1, 2, 3, and they're all connected to carbons, then there's 1, 2, 3. That's only going to be the sp2 hybrid. And then this concept of the layers that you can rub off with just a little bit of force when you're writing on a piece of paper, that fiber kind of the carbon embeds itself in the paper fiber. So that's the difference, 1 attachment. So here we go. Unlike a diamond, there are delocalized electrons. There's that word again. Unlike a diamond, the electrons are able to move around in the graphite. They got the delocalized electrons. And so graphite's actually a good conductor of electricity. You use it in batteries. It's softer, but it's a good conductor of electricity. And so if you're looking at differences, you can look at the hybridization difference. You can look at the electricity conducting, yes versus no. And you can look at the hardness difference, very soft or fairly soft versus very, very hard for the diamond. Then there's graphene. Graphene is used in a lot of things like touchscreens. Graphene is just a single layer of graphite. And so it would just be 1 layer. They use that in electronics a lot because it conducts electricity. So it can, pick up something like your finger touching a screen. And then fullerenes are just an extension of the graphene example, where you take a sheet of graphene and you connect it in a shape. And so fullerenes are the same. They're bonded to 3 other carbon atoms, just like graphene, just like graphite, same hybridization. But what happens is you can turn them into shapes. And these shapes are interesting because since it conducts electricity, these shapes are interesting to scientists as ways to create structures made of carbon that conduct electricity. And so carbon nanotubes are when you have a tube. This is a buckyball, so it kind of looks like a soccer ball, but it's just taking the graphite, the graphene, and turning it into shapes. So what do you need to know? The difference basically between diamond and graphite. So that's what you really want to know for the test, is you really want to know the difference between diamond and graphite. So make sure you got that. And then this was just in your notes. This is from the IB book, and you can go through and read about the differences. I'm not going to go through it because you have it. You can read it, but it talks about the layers, the shapes, all the same stuff I talked about. So, all right. And so I think I can go over just this last little bit of information about molecular and covalent bonding. Actually, I'm going to stop it here. Change my mind. I'm going to hold here. I don't think I have enough time to go through this and the metallic bonding. So this one will finish up with the graphite, graphene. Once again, I mean, there's some cool stuff out there. I tried to show you, like I said, the models I think are really cool when you're looking at these. So like this is a fullerene, and so it's the same concept. It's just now we've taken and we've put these together in a shape. And so that's the idea, have the shape. And that's why scientists like this, because if you can shape a thing, you can make a structure out of it. And so then that's something that makes scientists more excited is, hey, I can do something with the carbon. And so then there's a nanotube. And so structures that are hollow, they can use them to make, it's not like this is really, really weak. This can actually be pretty strong when you get a whole tube of these going. Not as strong as a diamond, but still pretty strong and conduct electricity. So, little tiny robots that go in and do things in the body.